In this video, we're going to have a side example or two, and we're going to use the law of cosines to solve it. We would generally use the law of cosines when we are given either two sides and an angle where the angle is between the two sides, which was dealt with in a previous video, or if we're dealt with a triangle that has three sides given and we need to find the angles, and the triangle is not a right triangle. So here's a situation where we have a non-right triangle. This is a side lengths 9, 7, and 10. And we're not going to get out our protractors and rulers and compasses. We're just going to draw a triangle. And this triangle is going to have side lengths angles A, B, and C. And the side length 9 is going to be across from the letter A because as a little application of the hinge theorem, the angle A is across from side A. And therefore, side B is across from angle B, and side C is across from angle C. Angle C is going to be our biggest angle. Angle B is going to be our smallest angle. Well, let's start off by finding angle A first. So the law of cosines states that A squared is equal to B squared plus C squared. And then what we're going to do is we're going to subtract 2BC cosine A to finish the formula. Now let's plug things in. So what do we know? Well, we actually know our side length A, and we know our side lengths B and C respectively, and plug the B and C in again into the equation correctly. And this is what we're trying to find. We're trying to find angle A. So this is going to be 81. 49 and 100 is 149, minus 2 times 70, which is 140, cosine A. Again, this is where you resist the urge to subtract the 149 and the 140, because this is analogous to saying if this is 149 minus 140x, we wouldn't combine this into making it 9x. So we have to move the 149 to the other side, and that simplifies to 0, and this makes a negative 68, is equal to negative 140 cosine A. Then we divide both sides by negative 140. There we go. That divides out. And this gives me 0.49, or a longer decimal than that. But this is the decimal that we would have in our calculator, and we would take the inverse cosine of it. Because to get rid of the cosine, we would take the inverse cosine of both sides, and that would mean that my letter A is equal to this angle, 60.94 degrees. So angle A is 60.94 degrees. Now you might be tempted to say, okay, great, now that I know that an angle and its corresponding side, why don't I use the law of sines? Well, the danger of that is that you're picking two sides in an angle to find the missing angle. I wouldn't do that. I try to never use the law of sines after the law of cosines. Use the law of cosines again and find another missing angle. Let's take angle, let's see, which one do I want to do? Angle B. Let's do angle B, and I'll change color here just so it's easier to see. And I'll kind of partition this out a little bit. So now I have B squared is equal to A squared plus C squared minus 2AC cosine B. So now we just plug in the things we know, being careful that this is 7 squared, and now we can do the A and the C, which is going to be 9 squared plus 10 squared minus 2 times 9 times 10 cosine B, because we're trying to find angle B in this situation. Well, 49 is equal to 100 plus 81, which is 181, minus 2 times 90, which is 180. Again, please resist the urge not to subtract these two, because this is multiplied by cosine B. We can't just say that this minus this is 1 cosine B. We have to subtract the 181 from both sides. Oops, 181. Pew! And this makes negative 132. And then we have that equal to negative 180 cosine B. Divide everything by negative 180. And we're left with the decimal of 0.73 repeating. Oops, that doesn't have the repeating bar on the top of it. The 7 doesn't get the repeating bar, it's the 3. All right, we'll get this right. So 0.73 repeating equals cosine B. I would keep that decimal in my calculator and hit second cosine to get the inverse cosine, and then take the inverse cosine of the answer, which is second negative key, and this gives you 42.83 degrees. Now to find your final answer is you're going to subtract these two angles from 180. So 180 minus 60.94 minus 42.83 is going to give you 76.23 degrees. And that is the answer for that set of angles created by three sides in the law of cosines. So for the next example, we are going to take a look at this triangle. The side lengths are given, so this is another side, side, side example. But if I taught this in class instead of making a video, I'd just barrel on ahead, not giving you any clues or indication what's going to happen. But since you're watching the video, and we're just making a random triangle without any measurements specifically or measuring anything, do you notice anything strange about these numbers? 3, 4, 5. They are consecutive, but this is something special about the 3, 4, 5 triangle that isn't special about other triangles with consecutive numbers like 9, 10, and 11. Alright, so let's get started with the law of cosines. So let's try to find angle A. So finding angle A is going to be our a squared is equal to b squared plus c squared minus 2bc cosine A. Well, we know our a in this case, our letter A, is 4. We know our b in this case. Our b in this case is 5. And our c in this case is 3. So on the triangle, this would be 4, this would be 5, and this would be 3. Minus 2 times 5 times 3. Cosine A. Alright, so we have 16 is equal to 25 plus 9. Do those three numbers ring a bell yet? Okay, well, let's keep going. This is going to be 30, cosine A. And so 16 is equal to 34 minus 30 cosine A. Again, resist the urge to subtract these two, but subtract it this way. 34 from both sides, and that makes a 0. And this makes negative 18 is equal to negative 30 cosine A. Divide both sides by negative 30. Simplifies. And this negative 18 divided by negative 30 is 0.6. And 0.6 is equal to the cosine of A. If I take the inverse cosine of both sides, what I'm left with on the right-hand side is the letter A, and on the left-hand side, what I'm left with is 53.13 degrees. So angle A is 53.13 degrees. All right, now, again, you may not have noticed something special about this triangle, but you will now, because as we move to the next part of the problem, where we're solving for, let's say, side length B, and again, b is going to be b squared minus a squared plus c squared minus 2ac cosine b. Something kind of cool is going to happen. So this means if I have the b squared here, I'm going to put my, let's see, 5 in there, so that would be 25. My a, that's going to be 4, so that is going to be 16. My c is going to be 3 squared, which is going to be 9, minus 2 times a times c, and my a and my c in this case are 4 and 3, so that makes 12, and then cosine b. So look what I have. 25 is equal to 25 minus 24 cosine b. Oh, check this out. I'm going to subtract 25 from both sides. Well, that's 0. Equals negative 24 cosine b. A couple students at this stage might say to themselves, well, there's no way the angle's 0, and you're right, the angle's not 0. Finish the problem. Divide by negative 24, and what you now have is 0 divided by negative 24, which is 0, is equal to cosine b. We take the inverse cosine of both sides. What is the inverse cosine of 0? And the inverse cosine of 0 is 90 degrees. This was a right triangle. In fact, it's one of the most typical right triangles. The 3, 4, 5 and all the multiple scalars of 3, 4, 5 is one of the most common examples that you can get. We can easily find the last missing angle by subtracting from 180, and that last missing angle is going to be 36.87 degrees. And what's interesting about this problem is that you have such really nice side lengths and you have such ugly angles. And the true is same. You can put up some really nice nice angles and get really ugly side lengths, really nice side lengths, really ugly angles. It's hard to find a lot of examples where everything's nice. But also I want to show that this problem right here could have been done this way as well, using just properties of right triangles. Because if this is 5, which is going to be our side length B, and our angle B is right here, then angle A is going to be the small, let's see, is it, which one is which? Okay, so this is going to be angle C, and this is going to be angle A, down here in the right corner. And you could have figured out these angle measurements by using inverse trig functions. Let's say you want to find angle A. We'll take the inverse tangent of 4/3, or if you want to find the angle C, take the inverse tangent of 3/4. It's all from the perspective of the angle you're looking at. So when you take tests, just be aware that every once in a while they'll throw in a right triangle in a section that was made for non-right triangles. Just be aware that if they tell you to do the law of sines or cosines with a right triangle, please do those. But of course, you could always use your right triangle trig instead. Thanks for watching.